Hello, in 7.5 we will be looking at tangents. So the lesson objectives: to use properties of tangents and solve problems involving circumscribed polygons. So first, what is a tangent? A tangent is a line touching at one point. So a line touching at one point. So here you can see that this line here is our tangent line, and the point of tangency is A. So that is the point on the circle and the line, or where the line touches the circle. So the point where the line touches the circle. So a common tangent is a line touching two circles, each only once. And so you can see here that it touches two circles once, and there's only one line. So that's a line of a common tangent. All right, so use a straight edge to draw the common tangents. So grab another piece of paper or a ruler or something, hold it up, and draw a line straight through those. Where do you think the tangent line would be here? You'd have to go kind of at an angle to hit them both there. And then here, since the circles are on top of each other, you'd have to hit where they touch each other. So the theorem is that in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. So that means here that this angle right here is a 90-degree angle because we have our tangent line, and then we have our radius. And so since those two touch right there, that angle is 90 degrees. So line L is tangent to circle S if and only if line L is perpendicular to segment ST. So that's saying that if this is a right angle, then this line is tangent. So that's just going the other direction. So it's an if and only if statement. So let's try some practice problems. So we want to know if segment KL is tangent to circle J. How are we going to figure this out? We want to know if this is a right angle. So seeing that both of these parts right here are radii, you can say that this part is 8, making the whole JK side 17. So does 8 squared plus 15 squared equal 17 squared? Yes. So therefore, it is tangent. Now, we want to check 6 squared plus 8 squared. And does that equal 12 squared? No. So it is not a tangent. All right, we want to find the value of x and assume that the segments that appear to be tangents are tangent. So we're assuming that that line there is tangent. So we need x squared plus 12 squared. And this whole side here is x plus 8. So we need that to equal x plus 8 squared. So we get x squared plus 144 equals x squared plus 16x plus 64. Cancel out our x squareds. Subtract 64 over, we get 80 equals 16x. So we get x to be 5. Working on the right now, here is our radius and our line of tangency. So here is our right angle. So we need x squared plus 14 squared to equal 17 squared. So we get x squared to equal the square root of 93, or approximately 9.64. All right, so another theorem. If two segments from the same exterior point of the tangent to a circle, then they are congruent. So here we have one point, and both tangents go to that point. And so that's saying that these two tangents, or these two segments here, are congruent. So if segment AB and segment CB are tangents to circle D, we want to find the value of x. Since they both go to point B, we know that x plus 15 is going to equal 2x minus 5. So we will get that 20 equals our x. Over here, they both go to point R, so we want to find the value of x again. So 3x plus 8 equals 26. So we get 3x will equal 18. So we get x to be 6 centimeters. All right, so one last problem here. So quadrilateral RSTU is circumscribed about circle J. If the perimeter is 18 units, we want to find x. So we have a few points on here. If we know that AS is 3, what else do we know is 3? Note that DS also goes to S, so that part is also 3. Going around, we can say that CR is 3, BU is X, and TB is also X. So we have 4 times 3 plus 4 X's is going to equal our perimeter of 18. So we'll get 12 plus 4X equals 18. So 4X equals 6. So X is going to equal 6/4 or 3/2. Thanks for listening. Quick and short. Good luck on the homework.